let's take a look at the system of nonlinear equation. We see we have a nonlinear equation here because the first equation y is raised to the second power. What that really means is that we have a parabola that is rotated in a 90 degrees, and I'm going to show you in a second on kind of visual so you have an idea. And we have y equals 2x minus 2. That is a straight line. How can we solve this? Do those two equations intersect at some point? Well, we either have elimination method or we have substitution method. So here it looks like what I want to do is I want to substitute. It says y equals 2x minus 2. I'm substituting into the first equation for y. So this becomes 2x minus 2 squared equals 4x plus 4. Now before I go on and solve this, you can see I have only one variable, and that's what I know how to solve. I want to do a little sidebar down here because 2x minus 2 squared really means 2x minus 2 times 2x minus 2, and sometimes this is a problem. So 2x times 2x is 4x squared minus 4x, I multiply these two, that's also minus 4x, and a plus 4. So now I can go ahead, copy this over here, and make sure that I combine these two like terms. 4x squared minus 8x plus 4 equals 4x plus 4. You can clearly see this is a quadratic equation based on the 2 there. How do we solve quadratic equations? We set them equal to 0. So let's bring a minus 4x and a minus 4 to the other side. And what happens here is we have 4x squared minus 12x, and you can see that the 4's cancel out, and that's equal to 0. How would you solve this now? Well, if it was me, I would want to think about factoring. Factoring is always good. We can factor this. Greatest common factor is 4x. And that leaves me with an x minus 3 equals 0. So now I set each factor equal to 0. And divide by 4. X is equal to 0. And here I'm going to add a 3, and you get x is equal to 3. Based on that, I'm going to find the corresponding y value. So what I'm doing is I'm substituting again. I'm substituting x equals 0 into this second equation and find y. Y equals 2 times 0 is 0. And all we have left is y equals negative 2. So my first ordered pair is 0, negative 2. Now I'm going to do the same with x equals 3. Y equals 2 times 3. Let me write it out. Minus 2. So that would be 6 minus 2, and I get y equals 4. And my second ordered pair is 3, 4. So these are the points of intersection. Now, if you graph this, and I'm just going to graph it real quickly, and in pre-calculus, you will definitely learn about conic sections and how to graph parabolas that are rotated. But this parabola rotation looks somewhat like that. Let's say here's negative 2, here's positive 2. And the y equals 2x minus 2. So 2x minus 2, they intersect right here. The slope is 2 and over 1. Then 2 and over 1. Here you go. So there is my second point of intersection. Oops. They intersect at 2 points, and this would be 3, 4, and here we have 0, negative 2. So more or less, this is a sketch of what we had presented right here with our systems of nonlinear equations.